On a fateful summer evening, August 15, 1977, a mysterious signal pierces the vast expanse of space, captivating the attention of astronomers at Ohio State University's Big Ear radio telescope. As the signal flashes across the computer printout, astronomer Jerry R. Ehman's eyes widen in astonishment. He circles the reading, 6EQUJ5, and scribbles a single word beside it: "Wow." This fleeting moment marks the beginning of an extraordinary journey, one that would spark intense debate and intrigue the scientific community for decades to come. The signal, originating from the constellation Sagittarius, appears to bear the hallmarks of an extraterrestrial transmission, leaving Ehman and his colleagues to ponder the profound implications. As the news spreads, the world becomes entranced by the possibility of life beyond Earth. The signal lasts for 72 seconds, a brief yet profound moment that will forever be etched in the annals of history, inspiring a relentless pursuit of answers to humanity's most fundamental question: are we alone in the universe? As the world becomes entranced by the possibility of life beyond Earth, we find ourselves at the Big Ear Observatory, a radio telescope facility nestled in the Ohio countryside. It is here, on a summer evening in 1977, that a team of astronomers, led by Dr. Jerry Ehman, are conducting a routine survey of the sky, searching for signs of intelligent life. The Big Ear, a massive radio telescope, is listening to the cosmos, tuning into the faint whispers of the universe. The team is using a unique measuring system, where the signal's intensity variation over time is expressed as a series of alphanumeric characters, with each character representing a 10-second average intensity minus the baseline. The signal intensity is measured as a signal-to-noise ratio, with the noise averaged over the previous few minutes. The signal is sampled for 10 seconds and then processed by the computer, which takes 2 seconds. The result for each frequency channel is printed as a single alphanumeric character, representing the intensity minus the baseline, expressed as a dimensionless multiple of the signal's standard deviation. This system allows the team to detect even the faintest signals, and it is this system that will soon reveal the wow signal's extraordinary intensity, with a peak value of U30 standard deviations above background noise. The team is comprised of dedicated scientists, each with their own unique expertise, working together to unravel the mysteries of the universe. As they pore over the data, they begin to notice something unusual: a strong, narrowband radio signal, unlike anything they have seen before. The signal appears to be an unmodulated continuous wave, with any modulation with a period of less than 10 seconds or longer than 72 seconds not detectable. The team's excitement grows as they realize the significance of their discovery, and they carefully verify the signal, checking for any possible errors or anomalies. Little do they know, they are on the cusp of a momentous discovery, one that will change the course of history and inspire generations to come. The stage is set for a drama that will unfold in the coming moments, as the team struggles to understand the implications of the signal they have detected. As the team at the Big Ear Observatory pores over the data, they begin to notice something peculiar. A signal, strong and narrow, is emerging from the noise. The frequency, 1420.4556 MHz, is tantalizingly close to the hydrogen line, a natural frequency emitted by hydrogen atoms in space. But this signal is slightly higher, by about 50 kHz, which could indicate a blue shift, suggesting the source is moving towards Earth at a speed of about 10 km per second. The team's curiosity is piqued, and they start to scrutinize the signal more closely. John Krause, the director of the observatory, and Ehman, the astronomer who first spotted the signal, are deeply involved in the analysis. They are aware that the telescope's radio receiver has a slight error in its local oscillator frequency, which was specified to be 1450.4056 MHz but was actually 1450.5056 MHz due to a typographical error. Ehman takes this error into account as he computes the frequency of the wow signal. The signal's bandwidth is remarkably narrow, less than 10 kHz, which is a tiny fraction of the overall frequency range. This narrowband emission is a characteristic that sets it apart from other astrophysical phenomena. The team is now fully engaged in the search for answers. They are studying the signal's characteristics, trying to understand its origin and nature. The Big Ear telescope's receiver is capable of measuring 50 10 kHz wide channels, and the output from each channel is represented in the computer printout as a column of alphanumeric intensity values. The wow signal is essentially confined to one column, a striking feature that suggests it is a coherent, targeted transmission. As the team delves deeper into the data, they are becoming increasingly convinced that this signal is not a natural phenomenon, but rather something much more extraordinary. The tension is building, and the team is on the cusp of a groundbreaking discovery. The signal is strong, and the implications are profound, but the team must verify the findings before they can be certain. The search is on, and the world is about to witness a momentous event. As the Big Ear radio telescope sweeps across the sky, it locks onto a mysterious signal, and for 72 seconds, the world holds its breath. The signal is strong, peaking at the center of the observation window, and then gradually decreasing as the telescope moves away from it. This is exactly what one would expect from a continuous extraterrestrial signal. The team's eyes are fixed on the data, their minds racing with the implications. They are witnessing something profound, something that could change our understanding of the universe forever. The signal originates from a region of the sky northwest of the globular cluster M55, in the constellation Sagittarius. The galactic coordinates pinpoint the location to within a few degrees of the 5th magnitude star group Chi Sagittarii. The team is aware that the signal could have come from one of two possible beams, but they cannot determine which one. The uncertainty only adds to the intrigue, as they struggle to comprehend the significance of what they are seeing. The 72 seconds tick by, each one filled with anticipation and wonder. The team is acutely aware that they may be on the cusp of something historic, something that could redefine our place in the universe. The signal's intensity, the way it peaks and then fades, all suggest that this is no ordinary phenomenon. As the final seconds tick away, the team is left with more questions than answers, but they know that they have stumbled upon something extraordinary. The signal's origin, its purpose, and its implications all remain a mystery, but one thing is certain: the world will never forget these 72 seconds of wonder. As the team at the Big Ear Observatory breathes a collective sigh of wonder, they are faced with the daunting task of unraveling the mystery of the WOW signal. The signal's origin, its purpose, and its implications all remain a mystery, but one thing is certain: the world will never forget these 72 seconds of wonder. Dr. Ehman, the astronomer who discovered the signal, is now consumed by the pursuit of understanding its source. He ponders the possibility that the signal could be the result of interstellar scintillation, similar to the twinkling of stars in the night sky, but this explanation does not exclude the possibility of an artificial origin. The Very Large Array, a significantly more sensitive instrument, is deployed to search for the signal, but it remains elusive, leaving Ehman to consider alternative explanations. In 1994, Ehman suggests that the signal could have been an Earth-sourced signal reflected off a piece of space debris, but he later recants this idea as further research reveals the unrealistic requirements for such a scenario. The signal's frequency of 1420 MHz is part of a protected spectrum, reserved for astronomical research, and terrestrial transmissions are forbidden, although instances of interference and illegal transmissions have been documented. Ehman resists drawing conclusions from incomplete data, acknowledging the possibility that the source may have been military or a product of Earth-bound sources. In a 2019 interview, Ehman expresses his conviction that the WOW signal has the potential to be the first signal from extraterrestrial intelligence. As the years go by, numerous attempts are made to detect the signal again, but it remains a one-time event. The lack of replication leads some, like Medi President Douglas Vakoc, to question the signal's credibility. In 2020, the Arecibo Observatory in Puerto Rico conducts observations that may shed new light on the mystery, and in 2024, the Planetary Habitability Laboratory publishes a preprint suggesting that the WOW signal was likely caused by a rare astrophysical event. Despite the many attempts to explain the signal, its true nature remains a mystery, leaving the world to wonder about the implications of those 72 seconds of wonder. The silence that follows is deafening, but it also fuels the imagination and inspires further exploration. The WOW signal may remain an enigma, but its impact on the scientific community and the world at large is undeniable. The WOW signal may remain an enigma, but its impact on the scientific community and the world at large is undeniable. As we continue to search for answers, the signal's legacy extends far beyond the confines of the Big Ear Observatory, inspiring new generations of astronomers and researchers. In the years following the detection, several attempts were made to recover and identify the signal, with astronomers like Ehman and Robert H. Gray leading the charge. Gray's searches in 1987 and 1989 using the Meta-Array at Oak Ridge Observatory, as well as his later efforts with the Very Large Array, have all yielded null results, leaving the signal's origin and nature still shrouded in mystery. As the years went by, the wow signal became a cultural phenomenon, captivating the imagination of people around the world. It has been featured in various forms of media, including the 1994 Season 2 premiere of The X-Files, where the signal is referenced in the episode Little Green Men. More recently, the signal was featured in the 2024 television series Three-Body Problem, where it is detected in Inner Mongolia. The English progressive rock band Muse is even set to release an album titled The Wow Signal in June 2026, a testament to the signal's enduring fascination. In 2012, on the 35th anniversary of the wow signal, the Arecibo Observatory beamed a digital stream towards 3 nearby stars, including Hipparcos 34511, 33277, and 43587. The transmission consisted of approximately 10,000 Twitter messages, bearing the hashtag chasing UFOs, as well as video vignettes featuring verbal messages from various celebrities. Although the transmitter overheated shortly into the first transmission, the event marked a significant moment in the search for extraterrestrial intelligence, as scientists attempted to increase the probability that any extraterrestrial recipients would recognize the signal as an intentional communication from another intelligent life form. As we reflect on the wow signal's legacy, we are reminded of the profound impact it has had on our understanding of the universe and our place within it. The signal may have been a one-time event, but its implications continue to inspire new research and exploration. As we push the boundaries of what is possible, we are driven by an insatiable curiosity about the mysteries that lie beyond our planet. The wow signal may remain an enigma, but it has ignited a spark that will continue to fuel our quest for knowledge and understanding of the cosmos. As we look to the future, we are compelled to continue the search for answers, to push the boundaries of what is possible, and to explore the unknown. The wow signal's legacy is a reminder that the universe is full of mysteries waiting to be uncovered, and that the search for extraterrestrial intelligence is an ongoing endeavor that requires our collective efforts. As we venture further into the unknown, we are driven by a shared sense of wonder and awe, inspired by the possibility that we may not be alone in the universe. The wow signal's impact will continue to be felt for generations to come, a testament to the power of human curiosity and the boundless mysteries of the cosmos.